Welcome everyone again. I'm very happy to welcome all the people, speakers in the room and guests in the room, but especially also the online community for this afternoon session on the SCiON Day. It's really a wonderful time to see everyone again. The last SCiON Day was in 2019 in November, and a lot has happened since then. Unfortunately, I'll only have a few minutes to go into a few details what has happened in the last year. There's been a lot of research results that we've been able to contribute, and I'll just be able to mention a few highlights of new research results. And here, the first one is on globally secure time synchronization. That's a new project we've launched a few years ago, and now in the last year we've made a lot of progress on. I hope we can soon distribute the research results, research papers, but we have a first implementation that enables all hosts on the SCiON internet to be globally time synchronized with very high level of security. Another project I'd like to highlight is the Mondrian zoning system. It's a collaborative project with ZKB, and to facilitate secure zoning in corporations all the way to home users and as well as within cloud environments. Another exciting result we've been working on for over 10 years is the first globally scalable bandwidth reservation system called Colibri that we've also introduced in the SCiON Lab network last year, and it's now available for people to try out. And as well as the green routing system we've been starting to work on and have first results on to make use of SCiON to also not only optimize security or reliability or obtaining high performance, but also reducing the CO2 footprint for our communications. I'm also very happy to announce that last December in the CONEXT conference, the SCiON deployment paper has received the Best Paper Award and also one of the Best Presentation Awards. So that was a huge honor for us. And in that paper, we're able to demonstrate also the scalability of SCiON, that it's massively more scalable than the BGP or BGP-SEC systems that we're using today. In fact, so on this diagram, you see the overhead for running a BGP or BGP-SEC compared to SCiON for different autonomous systems. And so on average, we found that a ISP needs to perform about 200 times more effort to find the path in BGP and 1,000 times more effort to find the path in BGP-SEC than in SCiON. So lower here is better. So other highlights in deployment and developments, there are also many of them, too many to mention, but I'll briefly highlight the new ISPs that adopted SCiON, and there will be more about this afternoon. In the SCiON for ETH domain project, SCiET, a lot of the operationalization of SCiON was improved by applying SCiON to the ETH domain and different ETH domain institutions. The SBAS project, I'll briefly talk about a bit later in this presentation, and also the DR key systems and Colibri are now available in SCiON Lab, which is really exciting. In terms of new implementations, there also has been a lot of activities. For instance, the SCiON research lab in the Netherlands has built a P4-based SCiON router that can achieve more than a terabit per second of throughput. And a master student has built a video application, Jonas Gessner, that uses SCiON multipath for video conferencing, which showed the benefits of using multipath to obtaining very high quality teleconferencing communication. David Hauser's team in Magdeburg has built a link system to improve the reliability for IoT communications. And also other projects include Lightning Filter Hercules for providing high-performance file transfer, high-performance communications across SCiON networks. So especially though I'd like to highlight the SSFN, the Secure Swiss Finance Network, that was launched in 2021, and that has driven a lot of the deployments and a lot of the improvements on SCiON over the past years. So we'll also hear more about this in the afternoon. Last but not least, also the new SCiON book is finally completed. It's within days of sending this to the printer. It's not necessarily development or deployment, but we anticipate that the new book will serve as a blueprint also to create standards on SCiON. And for people interested in the book, please send me email if you'd like to get an early copy to take a look at this. Right, so just very briefly, I'd like to highlight the exciting aspect of multipath communication. In a way, we believe that once you can experience this, once you can experience the power of multipath, it's hard to go back to today's internet that has a single path communication. Because multipath gives you multiple path choices. So in SCiON, you can optimize, for instance, for latency, bandwidth, or privacy based on where your path goes through, or also optimize for lower CO2 or the jurisdictions your packets traverse. So this is a really exciting new world, new internet design that gives you all these different opportunities. So one brief example of how multipath can help you is looking at web browsing. So we looked at comparing to today's internet that only has a single path. How much would a low latency path help you in just simply downloading web pages? And we found that if there is a lower latency path available, that even if this path has very low bandwidth, we experimented with 1/20th of the bandwidth, so only 5% of the bandwidth of the regular path, a web page download for a website that is further than 30 milliseconds away was improved by 10 to 20%. It's the time. So that's really amazing. And this shows that simply with a software-based system, we can actually, with the existing internet, achieve dramatically faster web page downloading. Now, to deploy SCiON, and we've talked about this a lot in the morning, there are some obstacles. And we've known this from the beginning. And so now that a lot of the technologies are defined and specified and worked out and close to be implemented also in the production networks, we are changing our attention to taking a look at how we can provide the benefits of SCiON to current applications. And so here you see different technologies that we envision for making use of SCiON that shows what needs to change. And so the red symbol indicates that some work is needed, and the green symbol means that no work is needed, no change is necessary. And so in particular, there's one specific mechanism that is called SBAS that almost needs no changes at all by the application operating system or even most of the autonomous systems. And I'll go into a few more details how this actually works. In the morning, we had a talk by Pratik Mittal on this project, and we believe that this could be a good way for taking regular internet traffic and optimizing it with a SCiON backbone. So in essence, the way this SBAS system works, it's a interface, it's a bridge between the existing SCiON production network and today's internet. So what you can do is you take this SBAS system can take a regular IP packet and checks if a certain optimization will be possible within the SCiON network. So it's one of the communication parties does need to opt in. So they simply need to say, yes, I'd like to use such a system. And then they also need to say what they would like to optimize. So if they want to optimize for latency, CO2, or security, or other optimization criteria, this SBAS system analyzes the packet and sees if the SCiON network can be used to provide this optimization. And so the important aspect is that the client may be completely SCiON unaware, as is the regular server. And just in a nutshell, the way this system works is that the regular internet packet gets to SBAS because the customer opted in and said, yes, I would like to optimize based on, say, CO2. And then the system analyzes, can this optimization criteria be achieved by using this existing SCiON backbone? And if so, where should the packet go back on the traditional internet, because the destination is not SCiON aware in this particular example? And so we see a lot of exciting opportunities for making use of this system and having the benefits of SCiON without having to change without having to change much in today's internet and applications. So with this, also, again, the focus in this year for our research group in particular is to drive daily SCiON use. For instance, through mechanisms to enable home offices to benefit from SCiON, as well as cloud connectivity, and also directly building SCiON into applications. So even if there's no operating system support, enable the application to make use of SCiON. And so we're also planning to expand the ecosystem with new players through the SCiON Foundation, which you'll hear more also in the afternoon, and also through standardization and offering the first standard, base standard that then can be subsequently improved through further standardization bodies. All right, so it's been a long journey with SCiON for over 12 years. We've been on this journey, and we now have today an internet architecture that is faster, greener, and secure. And it's really exciting to see how far we have come with these ideas. And so many thanks to all of you who are joining us on this expedition towards building a new internet. And in fact, reflecting what is really the true joy on this project is not only the technology, but especially also interacting with all the individuals who are participating in this kind of impossible project to create a new internet, where a lot of people have thought, it's impossible to innovate and create a new internet. And so the individuals who do come along are really of a special kind, and that has been the true joy on this project. So with that, many thanks, and I'll hand it over to Florian.
Thank you, Professor Perrig.